All right, for example 2, just again, this is chapter 1.3, example 2. Engineers conducting an experiment in an accident reconstruction want to see how long it would take a vehicle on the highway to coast to a stop if the brakes were inoperable. Basically, if your brakes go out, how long will it take to stop? The first few seconds of the experiment are recorded, and time is measured in seconds, and the speed is measured in miles per hour. So we want to generate a linear function for this situation, and based upon the model, when will the car come to a stop to the nearest second? So, first things first, we got to find our differences. So, we're adding 1, 2 to 3 is plus 1, 3 to 4 is plus 1, 4 to 5 is plus 1. 65 to 62, that's minus 3. 62 to 58, that's minus 4. 58 to 56, that's minus 2. And then 56 to 53, that's again minus 3. So if we want to find our change in y, we have to add up all those differences. So minus 3, minus 4, minus 2, minus 3, and divide it by 4, because there are 4 of them, which that's what? 3 plus 4 is 7, 8, 9, 10, 11. That's negative 12. Negative 12 divided by 4 is, so the average change in y is negative 3. Actually came out nice and pretty. All right. So that's the first piece we need. Change in y divided by change in x, so negative 3 divided by positive 1 is negative 3. So we've got y equals negative 3x. Because remember, your slope is change in y divided by change in x. We also need our starting point, which they don't give us. They give us the 1. So we have to subtract 1 to get there. So we're going to have to do the opposite. We're going to have to add that average 3 to there. So that's a 68. So my starting point is 68. And there's your equation. There is a model, a linear model, that best fits this data. The second part of the question says, based upon your model, when will the car come to a stop? Well, when it comes to a stop, the miles per hour is 0. So we're going to plug it in for x or for y. We're actually going to plug it in for y. Yes, my first inclination was for x too. All right, but it's y because it's 0 miles per hour. My y value is the miles per hour. So I need to plug it in for y. So 0 equals negative 3x plus 68. I got to subtract the 68 to get it over to the left side, so minus 68 equals negative 3x. And when I divide by negative 3, I get x equals, that's what? 68 divided by 3, I don't think that comes out evenly. 68 divided by 3 is about, it's 22.6666, so that's 22, we'll just say 0.7 seconds. It's 22.7 seconds. Right. That's how long, according to this model, that's how long it will take the car to come to a stop. All right. Oh, go ahead and scroll on to you try it number 2 and see how you do. All right, for you try it number 2, Caleb's parents set up a checking account for him before college so that he will be able to pay the utilities for his apartment. He keeps track of his spending in the table below. Time represents the number of months, and the checking account is measuring in dollars. So, okay, so the balance, that's how much is in the account, and the time is how long it's been. Generate a linear function for the situation. Generate a model. Based upon your model, when will the checking account dip below $100? So, here we go. Again, the top part, going up by 1. They like going up by 1, don't they? Kind of nice. It makes life easier. The bottom part, we got to subtract. So 1355 minus 1550 equals negative 195. And let me just put the others up there right quick. And there we go. Those are our differences, which, again, they're not the same, but they're pretty close. So we're going to use them to find an average change in y. So the average change in y is negative 195. Minus 185, minus 192, minus 187, and since there's 4 of them, we're going to divide it by 4. So when you shove that in your calculator, you're going to get 189.75, so I'm going to round it up, 189.8. Okay, just round it up to 8 because of the 5 at the end. So if we're going to create the model, y equals the change in y divided by the change in x is still, I'm sorry, that's a negative over there, I apologize, because it's going down. Negative 189.8 x. And then the starting point, which was $1,550. So there is your linear model for this data. Then it says, based upon your account, when will the checking account dip below $100? So, here we go. $100, is that X or Y? The $100 is Y because that's the balance. So we're going to put $100 in there for Y equals negative 189.8x plus 1550. So we're going to subtract the 1550 minus 1550, and we get 100 minus 1550 equals negative 1450. So it's negative 1450 equals negative 189.8x. And then when you're multiplying, you have to divide to get rid of it. So we're going to divide by negative 189.8 in order to cancel that sucker out. So x, what did I just do there? Get rid of that dot. So x equals 7.6. Now question, we're measuring in months. It's not like this is continuous. In the middle of the month, it doesn't change. He takes this out every month. So the answer in some senses, you're right, we got x is 7.6. But really all of this is discrete. We only have whole numbers up here. So the question is, will it be below $100 at 7? Or will it be below $100 at 8 months? Because remember, 7.6 is between them. So we have to pick one of those two. Since the money is going down as time goes on, so if we go back up to the 7, the amount of money goes up. So it's going to be above $100 here. Alright? It's going to be below at 8 months. And if you don't believe me, shove in your calculator. Take y equals negative 189.8 times 8 plus 1550. In this case, y is going to equal 31.6. Right. So it dipped below $100 on month 8, but on month 7 it was probably still above because it took to 7.6 to get below 100. All right, and if that's messing with you, that's okay. You'll get used to that after a while. But because they want below, they weren't looking for an equal sign. They need to look for a range. Anyways.